Hello everyone, I'm Svitlana Galeshchuk and today I'm gonna present the results of my study on entity embellishment mitigation in large language model output. Text generation is the production of text based on an input, with applications such as summarization and chatbots and so on. Large language models have advanced the fluency and diversity of text, but are prone to creating incorrect or irrelevant information that we call hallucinations. This can pose ethical risk, loss of trust, and many other problems. Future research is crucial to enhance the quality and accuracy of generated text. In this paper, we focus on the faithfulness problem and context inconsistencies, in particular when large language model generated output is imprecise or untrue compared to the user's input. To give an example, Figure 1 illustrates the problem when a user asks an LLM to summarize a given article. We find some added information in the generated summary, the information on the nationalities of Tesla and Mercedes enterprises. While the nationalities given are being true, at least in 2024, it's not, however, mentioned in the article that Mercedes is a German car maker and Tesla is American. So it has been assumed by the LLM that this is probable information to be in the output. We refer to this type of context hallucinations that accompany named entities as entity embellishment and define mitigating them as the main scope of the paper. This brings us to the objective of the paper that aims at reducing the risks of context hallucinations in foundation models that we are trying to mitigate using summarization dataset and perturbated examples for model alignment via DPO procedure in the paper and share the results in the further slides. After highlighting the objective of the study, I will start explanation of the experimental setup from defining evaluation metrics, as it remains one of the main pain points of research in hallucinations by large language models. Traditionally, n-gram methods are considered, in particularly Rugel, that is also used in our study. But apart from this method, the feedback from another large language model is widely employed as well. And recent papers also propose a comparison between GPT-4 and human evaluation and prove their high correlation. Another approach that we find in the state-of-the-art is the evaluating on perturbated samples, which is creating a data set by corrupting golden summaries with some paraphrasing, entity swapping, and noise injection. The overview of this literature helps define also our experimental evaluation strategy by integrating different approaches together and going one step forward. So for this, we create a data set of adversarial summaries to golden summaries for news articles inspired by weakly supervised approaches presented that are used then as an input to LLM alignment phase rather than fine-tuning as what we usually see in state-of-the-art. We then apply GPT-4 to assess faithfulness of generated text, and I will give you more details on the setup in the next slides. We tested our approach on a summarization task using the Ukrainian part of the Excel sum dataset. Why the Ukrainian part is because we hypothesized that while hallucination is a problem for LLM for English corpora, it may be even more significant for low-resource languages as Ukrainian. So this dataset, XLM sum, is a collection of over 58,000 BBC News articles in Ukrainian and is considered as one of the benchmarks for comparison and evaluation for summarization and text generation. We used the first 10,000 examples for fine-tuning the large language model and the rest of the test split as validation set for alignment and test set for testing our approach. This slide discusses the experimental setup with the large language model Llama 2 from Meta. The setup involves several steps, including fine-tuning the foundation model on training data, generating summaries using the fine-tuned model on validation set, and assessing the level of faithfulness of hallucinations in the perturbated generated text as well. LLM fine-tuning is done using open source Python packages and specific training arguments that you can find in the paper. The first 10,000 of Excel sum train splits articles are used for fine-tuning, and we also use A100 GPU for the training. So how does it work in practice? First, we prepare the data for summarization, which is Excel sum. We split it on train, validation, and test. And the train set we use to fine-tune the Llama 2 model. After fine-tuning, the model is used to generate the summaries with validation set. We then use these generated summaries and corrupt them with GPT-4, injecting some additional knowledge in each of the generated summary. Then there is a phase of alignment, a fine-tuned Llama 2 with validation set, and both golden and perturbated summaries, when the golden summaries are the ones to be chosen and perturbated summaries are the ones to be rejected. Now we have fine-tuned model and aligned model to be compared. So for that we use the test set and we employ both fine-tuned and aligned model to generate summaries, and we do the evaluation with either Rouge-L metrics or GPT-4 to be a judge, an artificial judge in our setup. So let's zoom together on the alignment phase of the experimental setup. The fine-tuned model generates summaries for the articles from validation set, chosen based on the average length of the golden summary. The generated summaries are then corrupted with added noise from GPT-4 using also named entities extracted from Spicy NER model for Ukrainian language. How does it work? We use the prompt that is exposed on the left side of the slide with the following instruction and the user input, asking GPT model, please insert in the phrase information of up to 4 words about the entity. And the entity has been already extracted using Spicy model, and since there could be several entities, which has asked to insert additional knowledge only on the first occurred entity. Then, to give you an example, for some given text, the fine-tuned Llama 2 model generated in Kiev, street art is quickly expanding, said Mayor Klitschko, and the corrupted sample using GPT-4 will be, in Kiev, street art is quickly expanding, said Mayor Klitschko, a former boxer. The information that Klitschko used to be a former boxer was not given in the context of the article. As it has already been mentioned, we use Rouge-L and also GPT-4 for evaluating strategy in our study. So GPT-4, for example, has been exposed to both the article and the summary generated by 2 versions of Llama 2, fine-tuned and aligned as it has been described. And GPT-4 then has been asked to verify if summary is not consistent with the corresponding article. So the answer is yes or not. In the case of GPT-4, the higher means the better consistency, so less of hallucinations, meaning more yes in the answers. And in both cases, for Rouge and GPT-4 evaluation, we consistently saw that the aligned version of Llama 2 has been more performant in terms of reducing the hallucinations. You can find both fine-tuned and aligned versions that has been presented in this study on Hugging Face Hub. I invite you to test and give me the feedback. And I also thank you for your attention.